This is a test of live solution of the exercises given in the first tutorial. So the first, it's 1a. One wishes to determine psi of xt, solution of psi t plus exponential minus t psi x equals 0. And at t equals 0, psi of x0 is given. Okay, it looks like, say, something like that, the function of x. Okay. Well, let's use the method of characteristics and define psi of t, which is phi of xt and t, where xt is yet undetermined. And we will choose the most convenient x of t for us. So if you do that, you derive psi with respect to t. Well, there is a part which is just the derivative of phi with respect to t, and then, of course, dx dt psi x. And if you compare this expression to this one, one is led to think that it would be appropriate to identify dx dt with exponential minus t. In this case, well, of course, phi of t is a constant, because from here, comparing this expression with this one, it's clear that d psi dt equals 0. Okay, so it means that psi of xt and t is a constant along the characteristics, which is the curve obeying dx dt equals exponential minus t. Okay, so this is easily solved by integration. Means x of t minus x of 0, let's call it x bar to follow the notations of the lectures, equals, well, let us be slow, equals 1 minus exponential minus t. It means the characteristics equation are of the form xt equals x bar plus 1 minus exponential minus t. So they are easily drawn in the xt plane. Okay. Let me think a little. Say they start at some x bar, and then they should go this way, and the final is x bar plus 1. Okay. Yeah. This is it. Well, one has to think, but I believe, for instance, at low t, you have xt equals x bar plus t. Okay, one makes a first order Taylor expansion of this term, it gives t. Okay, and they all are the same. They only depend on x bar by the starting point, so they are all parallel, say, and all the characteristics are like that. I'm not drawing very well, but that's it. And this means, say, for a given here, point x and t. One knows that phi of xt equals phi naught of x bar, where x bar is the starting point where from a characteristic reaches xt. So this x bar here can be expressed as a function of the xt we are interested in, just like here it's x minus 1 plus exponential minus t. So it means that, and this is the end of, we solve the so-called Cauchy problem, the initial value problem. Psi of xt is psi naught of x minus 1 plus exponential minus t. And oops. And if you want to be sure of that, just check that indeed it works. So let's compute, say, psi t plus exponential minus t psi x, psi sub x, which was the equation we wanted to solve. So this is simply minus exponential minus t psi 0 prime of its argument, I don't write it, plus exponential minus t psi 0 prime, and indeed, that's 0. Just remark that also, since the characteristics are so simple, they are drawn here. At plus infinity, one has psi of x plus infinity. This is simply, look at this, this is simply psi naught of x minus 1. So for instance, if we had here a psi naught which was centered around 0, this would be psi naught of x. This guy here is centered, psi of x is centered around 1. So one has around 1. This would be just psi of x plus infinity. One has, it takes an infinite time to reach, to make this translation of 1 unit of space. So this is the end of the solution of this exercise.